Now let's go over what a queue is, and we are going to implement some methods for queue. Queue is a ordered list of elements. So it's like an R array where element is inserted at the end of the queue. So it's inserted at the end and removed from the front of the queue. So removed from the front. Queues follow first in, first out principle. And if you remember, what does stacks follow? Stacks follow LIFO, L-I-F-O, which is last in, first out principle. Meaning last item in the queue is last to be deleted and first is first to be deleted. And let's say we have our array, and when we are adding elements, we are just going to add elements at the end of the array. So just exactly like our push method. But when we are removing elements, it's always going to be from the front of the queue. So we get rid of 1 and 2, 3, 4, and 5 in that order. Now there is a limitation of queue, which is after elements are dequeued, that means removing elements. Elements cannot be added back at the beginning of the queue. In order for that to happen, the queue has to be reset. Okay, so let's go over this when we illustrate our example later. And this is an important part of queue. And this is a major limitation. And you are going to see this when we code our solution. But there is a solution to this. And that's going to be when we use or implement circular queue, and we'll just talk about that later. Now these are the methods that we want to implement, and let's just go over our time complexity really quickly. Well, our space is going to be O of n because it's gonna depend on number of inputs. Now access is O of 1, search is O of n because we have to iterate through all the elements to search for the value that we want, and insertion and deletion is O of 1. So deletion happens at the front of the queue and insertion only at the end of the queue. Well, insertion makes sense because remember that queue always inserts at the end of the queue. So that's O of 1 operation. We don't have to re-index anything. Well, deletion, if we were to delete in the front of the queue, how is that O of 1? You might ask, because if you remember from stacks and arrays that we implemented, if we were to delete an element, so this is our array and these are our values. If we were to delete our first element, that means that we have to re-index all our elements so that it looks something like this, right? And our index will be here and here and here. And this is O of n operation. Well, remember we talked about a limitation of queue. This is kind of going to correlate to that, and you'll know why it's going to be O of 1. And let's actually illustrate that right now. If you guys find this helpful, make sure you guys like and subscribe. Thanks. Now let's go over a step-by-step illustration of how queues work. Now let's say that this is our queue represented by variable a, and our queue is always going to have a certain size. And right now, let's just set it to 5. And it's going to have two more properties, which is going to be called the first and the second one last. So what does first and last represent? Well, first represents the first element in the queue. And obviously this one is the last element in the queue. Okay, that looks good. And we are going to set these two to -1 to start off with. So think of as we have -1 over here. And at first, when it's empty, our first and last pointer, so these are going to be our pointers, is going to be set to 1 because for now, we don't have any elements in our queue. Now let's add some elements. So step 1. So we have our array here, and when we add element, it's called enqueue. And let's just add an element over here, index 0. And just think of index -1 as imaginary. So when we add an element, right now, for now, we have only one element, right? So we are going to move our first and last pointer to over here. So first is going to point to this one, and last is going to point to this one, because right now we only have one element. Now let's add one more element, and also enqueue here. And we're going to have the number 2 here. And we have to move our pointers so that it points to the first one and last one for this one. And let's say that we did multiple enqueue operations and have this as our queue. And first, obviously, it would be this one, and last would be this one. So we enqueued a bunch of elements. But now we want to remove some element. And if we were to remove elements, we are going to go to our first pointer and get rid of that element. Now let's do that operation. So that's called a dequeue. So we wouldn't have 1 anymore, so that's gone. So we will have 2, 3, and 4 here. And last will obviously point to the same thing. And now our first pointer is going to be here. So it looks good now, right? But there is one thing that I do want to point out, and that's, if you remember from before, there is a limitation of queue. And the limitation is that when we get rid of elements, we are going to have an empty element over here. So if you were to add more elements, it would be at index 4, but we will never add an element at index 0 again. And if you were to dequeue one more time, now we get rid of this 2, right? The number 2. So we get rid of this, and we would obviously shift our first pointer to index 2. And now we would have 2 empty indexes without any values. So this is the limitation that we were talking about. We are going to have just empty values at index 0 and 1. And in order for us to, again, add elements to 0 and 1, what we need to do is we need to empty out the whole queue. So that's going to be look like, so we get rid of 0, 1, 2, and 3. So we empty it out, and we just reset our queue to our original state, which was this, where we make our first and last pointer to -1, and we just have an empty array. This might look confusing, but we will actually code our solution and this will make a little more sense. But do keep in mind that when we dequeue elements, we are going to have empty elements over here, which we can just call undefined or null until everything in our queue is emptied out. So that's why this is a O of 1 operations, because, well, when we dequeued our elements, we didn't re-index our elements so that this 2 is at index 0, 3 is index 1, and 4 is at index 2. Instead, what we did was, well, we know that this number is gone now. We dequeued it. So let's just put a null value or undefined value here and just move the first pointer to the correct place so that we don't have to do a O of n operation. That's exactly why deletion for queues are O of 1 instead of O of n, because we are not, again, re-indexing our elements. We are simply just moving our first pointer to the right. Now first, let's create our constructor function for our queue, and we want to give few properties. So first one is going to be store, where we set it equal to an empty array, and this is where we are going to store our elements. And next is going to be, we want to pass in the size for our queue. And so our constructor function for our queue is going to have a parameter named size. Next is going to be the first property, where it tracks the first position in our queue, and we are going to set this equal to -1. And last pointer obviously tracks the last position in the queue, and we want to set this to -1 also. Now let's implement our queue. So it's going to be function queue, and this is going to take a size. Now let's give our properties. So first one is store. This is where we store our elements. Set it to an empty array. The next one is going to be size, and this is going to depend on the size that's going to be passed in. And first is going to be -1, and this dot last is also going to be -1. So this is it for our constructor function, and let's check if this really worked. So let's instantiate a new instance of our queue, and new queue, and let's pass in a size of 3, and let's console log our queue here. You can see that we have our store, which is empty array, size which we pass in is 3, and first and last points to -1. And let's actually console log one more thing. So queue.prototype, and these are going to be our methods. And right now we haven't added any methods, so that should be an empty object. So that's it for our queue constructor. Let's move on to our methods. Now let's implement our enqueue method, where we add element to the end of the queue, and that's going to take a parameter of value. Now we need to check if our queue is empty. We want to set the first pointer to the first element. We just set it equal to 0. And next, we increment our last pointer by 1. And if you notice, it's different from our stack, right? Because before we set the element or the value that was passed in, and then we incremented our pointer. Well, the reason we increment our pointer first is because our pointer starts at -1. And if we were to reverse our operation, we will be inserting an element at -1, and that's not what we want. So let's implement our enqueue method. So that's going to be enqueue prototype, and enqueue, that's going to be a function which takes in a value. A value is the one that we want to add, and we want to check, well, is it empty? If it's empty, that means that our first is going to point at -1. If that's the case, I want to set my first pointer to 0. Okay, that looks good. And next, I want to increment my last pointer by 1, increment, and then we need to add the element to the queue. So this dot store at index this dot last, and set this equal to value. And at first, this makes sense. Just let's think about it. So we check if our queue is empty. If it's empty, we want to set the first pointer to index 0, and then next we want to increment our last index so that it becomes 0, and then next we add the value at index 0. So right now we have two elements or two pointers, first and last, that points to our first element. Let's try if this really worked. So let's do enqueue. So queue.enqueue. Let's push in 1, and let's first console log our queue. You can see that we have one element in our store, and first and last points to the correct index, which is 0. Now, if we were to add in more elements, now we added an element to the end of the queue. First one obviously still points at index 0 because we haven't removed everything. But now the last one is at index 1, which is the number 2. And let's just add in one more. 3. We have 3 elements to our queue now, and last one points to index of 2. Now let's implement our dequeue method, where we remove the element in the beginning of the queue, and we want to return the element that we removed later. First, we have to check, well, if the queue is empty, we just want to return because there's nothing to remove. And next, we want to create a variable to store our element that's going to be dequeued because we want to return that later. Next, we want to set the dequeued element to null. So technically, we are kind of deleting our element or overriding our value with null. And next, we want to increment our first pointer by 1 because since we removed the first element, we want the first pointer to point to the next element, which is now the first element. Next, we want to check, well, after we removed, if it happened to be the case that there was only one element in our queue, now it's going to be empty, right? If it's empty, we want to reset all the properties to its original state, so that later we can add more elements to index 0, 1, and 2. Okay, let's start implementing our solution. So that's going to be queue at prototype, and that's going to be dequeue, and that's going to be a function. And first we have to check, well, is it empty? So that means that if this dot first is equal to -1, we just want to return. Next, we want to create a variable to store our dequeued element, and that's going to be this dot store at index this dot first. And let's return our dequeued element here. And we spelled dequeue wrong. All right, that looks good. And now we need to override our dequeued element with null. So that's going to be this dot store at this dot first, and this is going to equal to null. And next, we want to increment our first pointer by 1. Now, if it happened to be the case that the element that we removed is the only element in the queue, we want to reset all properties to its original state so that we can add in more elements. So that's going to be if this dot first is greater than this dot last. We want to reset our store to an empty array, this dot first to -1, and this dot last to -1 also. And if you notice, we don't have this dot size, right? And we don't have to really change our this dot size because it never changes in our code. So now let's check if this worked. I'm going to just delete this, and let's do console log queue.dequeue, and it should return 1. So it returned 1, and then you can see that our store, our first element is now null, and the first element in our queue is this number 2, and last one is this number 3, which is our index 2. And let's dequeue one more time. Now we should have 2, and you can see that we only have the element 3 and everything else is overwritten and it's null now. And first and last points to the same thing. And let's just do one more time. And now you can see that our store is empty, our size is 3, and everything is reset. But let's go back up and try something else. I want to try uncommenting this out and see what I get. So if I were to uncomment that out, you can see that I just have an element with just null values, and my first pointer is greater than my last pointer because we removed everything. And if I were to just add in one more element, what would happen? Obviously, we wouldn't be able to add anything, right? Because it's full, but it's full with null values. And if you remember from our intro video, the limitation of queue is that once an element is removed, we can't add it back onto index 0 or index 1. What we have to do is we have to reset our queue. And if you were to go back up again, this is what we are doing here. We are resetting our queue so that we can again add more elements to our queue. So you saw that if it was the case that the first pointer is greater than the last, that means that our queue is full. So if that's true, we are just resetting all our elements. And again, we don't change the size because size never changes. Now, if we go back down, you can see that after we removed everything, everything was resetted, and we are able to again add more elements here. So we have one element here, size is still 3, first and last points to the first element, because right now we have only one element, and everything's working again. And I do want to point out one more time, so as we are adding more methods, you can see that we implemented our enqueue method and our dequeue method over here. Now let's implement our peek method where we return the element at the beginning of the queue. So that's going to be the first element in our queue. Let's implement it. So prototype, that's going to be called peek, and it's going to be a function. And we just simply return the first element in our store, and that's going to be at index.this.first. And let's test our code out. So if I were to do console log queue.peek, we have 1 because we have 1 as the first element. But if I were to dequeue a number, we should get 2, and so on and so forth. So that's it for our peek method. Now let's implement our rear method, and this simply just returns the element at the end of the queue. So peek return the first one, rear is going to return the last one. We just want to see what it is. We are not deleting it, we are not doing anything with it. So queue.prototype.rear going to be a function, and we want to return this .store, and our last index is represented by this .last, and that's it. So let's test our code, and let's change it to rear, and we should get 3, which is the last one. Well, if you were to remove an element, we should still get 3. If you were to remove it, it's still 3, and if you remove it, we have undefined because we don't have any elements. So that's looking good. And let's move on to our next method. Now let's implement a method where we check if the queue is empty or not. And this is going to be pretty simple. So queue.prototype.isEmpty is going to be a function. How do we know if a queue is empty? Well, if it's empty, this .first is going to be equal to -1 because we don't have any elements. And you could just do this .last is equal to -1, which is the same thing. So let's check if our code worked. So we should have console log queue.isEmpty, and we should get false because we have elements in our array. And let's just remove everything. So now it's true. So that's it for our isEmpty method. Now let's implement isFull method where we check if our queue is full or not. That's going to be queue.prototype is full, and that's going to be equal to a function, and we return. Well, how do we know if a queue is full? Well, that means that the size is going to equal to the last pointer plus 1. And we kind of went over this when we implemented our enqueue method where we check if it's full or not. So our size is 3, and when our queue is full, that means that our last is going to point at index of 2 because index starts at index of 0. So 0 is the first element, index 1 is the second, index of 2 is the third element. So index is 1 less than the size. So we add 1 to check if it's full or not. So let's test our code. So it's going to be is full, and that should give us true. And if you were to just remove one element, that should technically still give us true, because remember, when we are dequeuing elements, we are technically overriding it null. And if we wanted to add more elements right now, we can't, because our queue is full. And this is a limitation of queue, because even though we know that this is empty, we can't add more elements. So that's why our queue is still full. But if you were to get rid of everything, now when we have a truly empty queue, it's false. I know that this concept might be a little weird because we have a empty array or empty element that's really nothing. But in order for us to have a deletion time complexity of 001, we can't reindex our elements. So that's why we have to say that this queue is currently full. And later we are going to implement a circular queue where we solve this problem, but let's save that for later. For now, just know that even though we have technically 2 elements in our array, it's currently full because we haven't yet reset our queue to an empty array. Now let's implement our method where we return the length of the queue. So this should be really simple also. So that's going to be queue prototype length, and it's going to be a function. And we are going to simply return this dot last minus this dot first, and we add 1 to that. And I'll explain why we have to add 1 to that later, but let's see if this works or not. So let's console log queue.length, and that should give us 3, which is correct because we have 3 elements. So why do we have to add 1 after we subtracted first from last? So let's just look at these 2 numbers. Well, our last is going to be 2 when we have 3 elements, and if you were to subtract 0, that would be 2 minus 0, which is 2. Well, does that represent our length? Well, it doesn't, right? Because this is just simply an index, and index starts at 0 for arrays. So we have to add 1 to account for that 0's index. Now, if you were to just delete 1 element, you can see that our last is 2 and first is 1. So 2 minus 1 is 1. And we want to add 1 to our length because, again, it starts at index of 0. Now, let's implement our clear method where we clear all the elements in our queue. So that's going to be queue.prototype, and it's called clear. That's going to be a function. And what we do is we reset our store to its initial value, which is an empty array. We reset our first to -1, and we reset our last to -1. And we don't change our size because, again, size is given input and it never changes. And we talked about that when we implemented our dequeue method. So this is it for clear. And let's try if this worked. So let's do console log queue.clear, and that should remove everything. And actually, we don't have to console log anything. So let's do queue.clear, and you can see that everything was reset to its original condition. We have an empty array. First and last is set to -1, and our size is still the same. Now let's implement our last method where we print all the elements in our queue. So that's going to be queue.prototype, and we need to name it, obviously, print. That's going to be a function. Now we have to iterate through all the elements in our queue and print the values out. So let's use a for loop, and index is going to start at this dot first because that's obviously our first element, and we do it until I is less than this dot last plus 1, and we increment by 1 each time, and we just console log our element. So that's going to be this dot store at index I. So let's test our code. So queue.print, and you can see that here it's printing all the elements. So 1, 2, and 3. So if you were to remove 1, we would print 2 and 3. We will get 3 and nothing. So that's it for our print method. Now let's refactor some of our code to make it more easy to read, and it makes the overall code more simple. Now for the first one, we are checking if our queue is full, right? So what we can do is we can actually use the method that we implemented earlier. So that will be isFull method. And if that evaluates it true, we just want to return. So what we can do is we can just do this dot isFull. And if this is true, we will just simply return, just like the above code. Okay, and next one is checking, well, is the queue empty? And if it is, we are setting our first pointer to index of 0. So same thing. What we can do is we can use the isEmpty method. We can just do same thing. This dot first is equal to 0. So this way, the code itself is more intuitive. It's just literally saying, well, is this full? If it's full, we just want to return. Is this empty? We just want to set the first pointer to 0. Now let's refactor our dequeue, and first statement is checking if it's empty, and we can use our isEmpty method for that. So we use this dot isEmpty. If this is true, we just want to return. And next is this if statement. Well, we know that if the first pointer is greater than the last, that means that we have our queue only full of null values. So it's technically empty right now. And here we are resetting our queue into its original state. So let's first comment this out and code our solution. So it's going to be this dot first is greater than this dot last. And if this is true, we just want to run clear method. Now let's check if that worked. So we dequeue an element, dequeue, and if we dequeue, this should be reset to its original state, and it's looking good, right? It's working well. If you guys find this helpful, make sure you guys like and subscribe. Thanks.